In this video, I'd like to very briefly just talk about testing. Matthew makes very important points here, and it's worth your while scanning these and looking at these lecture notes. A very good example he supplies is this one here. You've got a function in worksheet 2 called distance between points, and it asks the user for 4 values. How do you actually work out what good test data is? And what he recommends is that thinking about what is a good test is almost as important as writing the code itself, because sometimes you can write a piece of code, throw a random value or whatever, and you think, yeah, it works, perfect, excellent, but you haven't really tested it. You've put no thought into it. It's very rare in the process of learning to write code that you approach your life like that. There is this very simple loop here. Now, there are 3 steps that you typically do. An experienced programmer can design the program or piece of program in their head, and some of you will be able to do it. Some of you need to make notes when you design stuff. When you're trying to design it and you sketch it on a piece of paper because you can't quite get it, don't feel bad about it. It's absolutely crucial that you're able to think through what your code should do. When you implement your code, you basically write your program. Okay? And there are all the rules about reading, legibility, readability, and all this kind of stuff. But an element of your programming cycle is testing. You've got to test the bit of code that you've just created or designed. Because actually, a lot of professional engineers work in this way. They create a very simple loop. So they've got a piece of code to write, they design it in their heads or on paper, depending on their level of experience. They might chat to a team. They then go and write it, but they immediately test it. And often what you find is that testing and implementing bounce back and forth. You test it, you realize there's something wrong, you go back, you change the code that you've written, you test it again. But once you've tested it and you're happy with that bit of code, you often loop back and you design another part of your program. So you get in this circular motion, and there are words for it. These are called iterations. And as you go through the degree program, you'll find that this method is very, very popular and very sensible when you're trying to write code. You design something. If it's too big a problem, take a tiny piece of it, write it, then test that tiny piece back and forth, make sure the code is right, then come back to your design stage, extend your design, add the other bits, develop that, and so on. So you go around this loop cycle. So testing and testing well is absolutely critical. So when you're testing a function like distance between 2 points, it's actually really useful to write it down so you can calculate. If it's complex, it's probably a good idea to get a pen and paper or a calculator and double check your results are correct. So I would probably encourage you to think more seriously about testing, and really, really good programmers do these 3 cycle steps very closely together. You design a bit, you run it, you build it, you test it, you bounce that back, come back to the design, you edit it, you expand it, and so on. Now, I can guarantee to you that when you come to your courseworks, you will be using a cycle like this. You'll take a tiny piece of the problem you're given, design it, build it, run it, make sure it all works, then loop back round, design a little bit more, expand it, and then carry on. So don't dismiss this as well and think this is just a technical degree. At the technical issue, sorry, not degree, it is hugely technical stuff. From practical worksheet 1, Matthew gave you a future value which had an interest rate of 5.5. A really good question to end on is, how do you know that works? What was the test data that you actually used? You need to generate some kind of test data to say that if you enter a 10-year period with an interest rate of 5.5 and a starting value of £3.65, you should know what the correct answer is. And you should test your code against it. So try to avoid the habit of just running a bit of code and it doesn't throw an error, therefore you're happy. Okay, try to avoid that.